Hi, this is Rick Powers calling, and I am going to do a recording of lesson number 10, Basic Statistics for Western Technical College. Greetings, this is Rick Powers calling from Western Technical College, Basic Statistics. Lesson number 10, Describing Data, Part 6, Percentile, Quartile, Box Plot. In the previous lesson, we went through a description of the z-score, which is a measure of the variation of a data value from the mean. This is a measure of position, looking at where a data value is compared to the other values in the data set. Another common way to describe the position of a data value is by way of percentile. The percentile of a data value describes how much of the data set is lower than the specified data value. For example, if there's some way to measure the amount of motion sickness that people get, then I might be in the 90th percentile. That means 90% of people get less motion sickness than I do, so I'm pretty high on the scale. Many areas of scientific research use the concept of percentile. One of the most common is comparing child development, as in your child is in the 15th percentile for height, which means they're pretty short. Another use of percentile is to split up a data set into 4 groups, where each group contains 1/4 of the data. The data values to separate those groups are called quartiles. Also, the groups themselves are called quartiles. If we had a child below the 25th percentile for height, then we could say the same thing in 2 ways. The height is below quartile 1, referring to the first quartile as the data value that splits the groups. Or the height is in the first quartile, saying it's in the lowest 25% of the data. So then, the data value that splits the data set at the 25th percentile is Q1 or quartile 1. At the 50th percentile, quartile 2. At the 75th percentile, quartile 3. Thus, the median is the same as quartile 2. Also, some software uses Q0 as the minimum and Q4 as the maximum. Here's an example. Ages of people selected for a research study. There's the data. Note that the data is in order. The median splits the data into 2 groups based on the number of items. N, or the sample size, is 12. Then the median is between 63 and 65. So Q2, quartile 2, is 64. There's the data. To find quartile 1, we take the group of data which is below the median and find the median of that group. Here are the list of 6 numbers that are below the median. And the median of those 6 then is quartile 1, which would be 63. Q3 is the median of the upper half. So we have 6 numbers which are above the median. And the median of those numbers, quartile 3, then would be 67.5. There is a measurement that some textbooks consider important, which is Q3 minus Q1. It's called the interquartile range. Some textbooks use the IQR to determine outliers. However, there are disagreements about what is the best formula to use for that. In this course, I want you to use the subjective definition of outlier, which is data items which are separated from the main data set. Note that this is not the same idea as unusual values, which are measurements that occur less than 5% of the time. Our next topic is to make a graph that represents the data groups created by the quartiles. This is called a box plot, or also a box and whisker plot. The first step in creating a box plot is to have an evenly spaced horizontal scale, which includes all of the data. This is the same requirement as the dot plot. Next, determine the 5-number summary, which are these numbers: the minimum, quartile 1, quartile 2, quartile 3, and the maximum. Then make a box using vertical lines above the values for Q1 and Q3. Insert another vertical line to indicate quartile 2, or the median, inside the box. Finally, draw a horizontal line from quartile 1 to the minimum and from quartile 3 to the maximum. These are the whiskers. It's important to have even spacing on the scale in order to have an accurate comparison of the whiskers. Here's the data, recall, and here's the 5-number summary. 59 is the minimum, quartile 1 is 63, quartile 2 is 64, quartile 3 is 67.5, the maximum is 74. So here's the box plot. So what information do we get from this? Specifically, the right whisker is longer than the left one. So the top 25% of the data is more spread out than the bottom 25%. So this indicates a right-skewed data set. Another important idea about the box plot compared to the histogram. It is not constructed based on any choices that we have to make about the scale. It's all determined by the data itself. That's an idea which can help us, especially when comparing multiple data sets, to see if there are any clear differences. However, there are 2 big problems with box plots. The groups don't really tell us what to expect, since all the percentages in the groups are 25%. There's no detail regarding gaps or clusters in the data, so we really can't see how the data is behaving. Let's now look at the dot plot of the data. We can see the right skewed shape, and we can also see gaps and clusters of data. Dot plots are generally better than box plots. Note, although you could create box plots by hand, it's important that you understand how to use software to make them. Of course, it's also important that you understand what they represent. That's the end of lesson 10.